All right, we're going to start Unit 3 now. And a lot of the topics of Unit 3 talk about chemical and physical changes. And we're going to start talking about reactions too. So we'll start balancing reactions. We'll talk about mass relationships, mole relationships, and reactions. So to get started, let's discuss the differences between physical and chemical properties. So a physical property are characteristics that can be measured without changing the material. So can be measured without changing the material. Examples of this would be flavor, smell, or density. Chemical properties, on the other hand, are characteristics which describe how a substance reacts. For example, whether an object can burn in air or not would be a chemical property. So I've listed some properties and I want you to classify them as chemical or physical. So the explosiveness of hydrogen gas, that would be a chemical property. The bronze color of copper, on the other hand, would be physical. The shiny appearance of silver, again, physical, you don't have to change anything. And this last one, the ability of dry ice to sublime, that's where you change from solid directly to vapor. This one at first appears like it would just be a physical property. But keep in mind, a physical property can be measured without changing the material. So dry ice subliming is changing. You're changing from solid directly to vapor, which is another word for gas. So this is a chemical property. Now we're going to talk about physical and chemical changes. So a physical change is the change of one state to another, such as melting or freezing. And that's what's really going on with dry ice subliming. Even though it's asking you to classify it as a physical or chemical property, it's really a physical change. So change of one state to another. And I don't mean like moving from Kansas to Missouri. I mean changing from solid, liquid, or gas, going back and forth. So change of one state to another. So such as melting or freezing. So the substance is still the same. Water is still chemically the same, whether it is solid, liquid, or gas. So physical changes can also include breaking something into smaller pieces. So when you were little, if you ever broke anything, like a piece of glass that might have been on a table, a big, thick piece of glass, that would be me. When I, as a child, broke this piece of glass, it is not that I changed the glass. It was once a big piece of glass, and now it was tiny little pieces of glass. So that is still a physical change. Now, a chemical change, on the other hand, is when you change into a different substance, such as burning natural gas to form carbon dioxide and water. So change into a different substance, burning natural gas to form CO2, carbon dioxide, and water. Another example of a chemical change would be using electricity to decompose water into oxygen and hydrogen. A mixture of oxygen and hydrogen is very different from water. You can breathe one, but not the other. So, I have another question for you. And notice this says to classify each change as physical or chemical. So copper metal forming a blue solution when it is dropped into colorless nitric acid. That would be chemical. A train flattening a penny placed on a railroad track. And so it's still a penny. You're not changing that, but you are changing the physical state of it. You are smushing it. Very technical term. No, you are taking this solid and transforming it into a different type of solid. It's just a different shape. So this would be a physical change. Ice melting into liquid water. Again, water as ice is the same as water as liquid. So this is a physical change. A match igniting a firework. That is actually a chemical change. So on to the next page, we are going to discuss the properties of solids, liquids, and gases. And these are states. So states. They're not the 50 United States of America, but they are states. In chemistry, states are very important. So let's discuss shapes of solids, liquids, and gases. So if you think about these states, and we've all interacted with these. I think if you ever watch children play, especially toddlers, they're fascinated by water. They're these little scientists trying to figure out what is this mysterious thing. And then they do the same thing with solids. Think of how much small children play with blocks, and they stack them and they fall over, and all these different interactions with the world. So you and I have been interacting with the world for a long time. We are aware of these different properties of solids, liquids, and gases, but we probably haven't thought about them enough to put it into a table. So you know this. You just don't know it in terms of chemical speak. So let's go through this. So a solid has definite shape. And think about that block that you grasped as a young child. You could feel that this cube had sides. It was solid. It definitely has shape. In one of our chemistry classes, we have students work with wooden blocks for several weeks, measuring the volume, calculating the density. So solids have definite shape. Now liquids, on the other hand, this is where you might get into trouble if you have kids and they want to play with water and they don't understand that water can be very destructive. But liquids take on the shape of a container. So whatever a container. Gases also take on the shape of the container. All right, volume. A solid has definite volume. A liquid also has definite volume. Think about when you go to the store and you buy a 2 liter of whatever, maybe 2 liter pop or 1 liter of something else. There's a volume. So liquids have definite volume. And a gas takes on the volume of the container. So the arrangement of particles. Solids have a fixed arrangement, fixed particle arrangement, and they are close together. A liquid has a random arrangement, and the particles are close. But not as close as a solid. I'll put a little star by that. And then a gas has, again, a random arrangement, just like a liquid. The particles are far apart. So when I was taking physical chemistry as an undergraduate, which another name for this chemistry is P-Chem, and it's notoriously difficult. Everybody says, oh, P-Chem, I can't become a chem major because of P-Chem. But I was in this class, and I had a group of friends that we would all study together. And one of our friends, she would always come up with the craziest things to remember stuff by. And she would put herself in the mind of a chemical. It sounds really funny, but I would always remember stuff that Molly said. So Molly, one day we were talking about the different properties of states, different things about solids, liquids, and gases, just as we're doing here. And Molly said, I think I would be a liquid. Liquids are my favorite, and then you just see Molly being a liquid. It's random, but kind of close together, but yeah. So I move on. So particle interaction. Solids have very strong particle interactions, while liquids just have strong interactions. And gases, remember, they're far apart. They don't want to be near each other. They have weak particle interactions. So you kind of get the feeling how my friend Molly would come up like, oh, I can identify most with a liquid. Not so much with a gas. More, not a solid. So, okay, particle movement. Solids move very slowly. Liquids move moderately. And gases move very fast. Okay. So we've talked about the properties of solids, liquids, and gases. Now we're going to talk about the changes of state. So you can see a lot of these diagrams, which we have on the notes. I like to use this diagram. So it's possible to change from one state to another by adding or removing energy. So melting is the change from solid to liquid. And freezing is the change from liquid to solid. So you have a solid at the bottom, you have liquid in between, and you have a gas up top. So the change from solid to liquid is called melting. And we probably are most familiar with this with ice. You leave an ice cube out on a countertop, it's going to melt. Think of snow, ice, when we're in the winter months. All right, liquid going to solid would be freezing. All right. Now, a liquid going to gas is called evaporation or boiling. So we're probably most familiar with it as boiling. Another term, evaporation. And then a gas going to liquid is called condensation. So that mysterious process when you have a glass that sweats, the gas around this glass is getting converted back to a liquid because it's getting cooled down. So there's water in the air. So that's condensation. Now, so we're probably more familiar with solid to liquid, liquid to gas. There is another type of change of state going from solid to gas and gas to solid. So sublimation is the change from solid directly into gas. So this is sublimation. And sublimation is something that you see a lot at Halloween. Those fog machines, that is dry ice. So it's called dry ice because it goes from CO2 solid to CO2 gas. And if you've ever been shipped something on dry ice, it's kind of cool because water goes from solid to liquid to gas, which would not be cool if somebody sent you something on just water ice, right? Because by the time you open it, it would be a pool of liquid and it could have done a tremendous amount of damage to your home and whatever the contents of this package may be. However, since dry ice goes directly from solid to gas, you don't have that irritating liquid in between. So that's why a lot of food is shipped on dry ice. Now, gas going to a solid is called deposition. So frost forms from water vapor in the air. It does not need rain in order to get frost to form on the ground. So think of frost for deposition. So we covered physical and chemical properties, physical and chemical changes. We talked about the states, solids, liquids, and gases, their different properties. And lastly, we talked about solids, liquids, and gases, how they can change to one another. That concludes our lecture for now. I will see you next time.